So we figured out that the two graphs are going to intersect at 20, 52, which means that at 20 years, both sharks will be 52 centimeters long. So what we want to figure out now is if the growth rate continues, how long will each shark be in 25 when they are 25 years old? So what we want to know is what is the y when x is 25 for each equation. So I could plug in 25 could plug in 25 for x here and see what I get for y for the Greenland shark, or I could do it using my graphing calculator. So I'm going to go back to my graphing calculator, and I need to know for y1, not for y2, for y1, what is the y when x is 25. So if I'm in the graph screen, I can press trace, and notice at the top of the calculator it says y1 equals, so that's the equation I want to be on. And so I'm just going to punch in 25 for x and press enter, and it tells me when the Greenland shark is 25 years old, it will be 55.75 centimeters long. So 55.75 centimeters long for the Greenland shark. And for the spiny dogfish, I want to know what is the y when the x is 25 again. So I could plug in 25 for x and figure that out by hand. Or I could just, since I already have my equations in my calculator, I could just press trace. And notice when I press trace, I'm on the y1, but now I want to be on y2. So I'm going to you can press the up or down, and it goes back and forth between the two graphs. I want to be on y2 now. So what I'm going to do now is I'm going to punch in trace, and then go up to be on y2. Now I'm talking about the spiny dogfish. So I'm going to punch in 25 for x. And at the age of 25, the spiny dogfish will be 59.5 centimeters long. Okay, so we can classify a system of two linear equations by the number of solutions. So we have two types of solutions. We have a consistent system, two types of systems. We have a consistent system. A consistent system has at least one solution, and an inconsistent system has no solutions. So if the system has solutions, it's called consistent. And if it doesn't have a solution, then it's called inconsistent. And if a system is consistent, it is either independent, which means exactly one solution, or it is dependent, which means infinitely many solutions. So I have a little chart there. And then we can also look at it graphically. Let's put it all together, what we've learned today. We've learned that there are three types of systems with linear equations. The first one would be if the two lines intersect. The two lines intersect, then the system has one solution, and it is a consistent, independent system. If the two lines are coinciding, which means they're exactly the same line, then that system has infinitely many solutions. They will intersect infinitely many times, and that system is consistent but dependent. And then lastly, if the two lines have the same slope but not the same y-intercept, then they are going to be parallel. And if the system has two parallel lines, then the system has no solution, and we call it an inconsistent system. So without graphing, we could tell whether this system is independent or dependent, or maybe it's inconsistent, by putting the two equations in slope-intercept form. If we put both equations in slope-intercept form, then we can look at the slopes, and we can look at the y-intercepts and determine what type of system we have. So the first equation is 1/2 x plus 3/2. And in the second equation, all we need to do is divide by y there, because it's already 8y by itself. So by 8, excuse me. So we're dividing by 8, and we get y equals 1/2 x minus 3/2. So it looks like we have a system that has two lines with the same slope, but not the same y-intercept. So these two lines are going to be parallel. So we've got two lines that are parallel. So in this case, we say that the system is inconsistent. So we have an inconsistent system.